I posted about this book yesterday or the day before. I'm not sure when I'm posting this video. But I really like this algorithm design manual book. It's helped me a lot out over the years, understand algorithms, understand thought processes. It's just a really good read. No, it's not for everyone. It's a very simple book compared to other books I've looked at, but it's engaging for me. And I'm actually going to, I think, talk about this book over the next few weeks and talk about what's in there and some of the things in it and how I'm studying it to review for possibly getting back in the job market. I haven't made that decision yet, but chapter 10, How to Design Algorithms, is one of my favorite chapters because it's great, like a great way to understand how to think. And I feel like as data scientists, thinking is literally your job. Like software developers, they think, but it's not an ongoing process. Like I talk to them and they say I make their heads hurt. And in my opinion, software development makes my head hurt. So we're even. But it's about how to think about problem solving or developing something to solve that problem. And that's kind of the core of data science. How do I solve the problem? How do I answer an open-ended question? How do I pull a bunch of things together to make something new? And in this book, that is basically an algorithm. So it walks you through the steps. And the first step would be, do I really understand the problem? Which I think is perfect because most people don't understand the problem. And I've fallen prey to this where I'll like, oh, I can solve it. I know the tool for that. And that's not really what they wanted. And then I jump all over me. We have to go back to basics and get a thorough outline. So what inputs are you taking in from them? What data do they have available? What data do they not have available? Like you need to know all of that before you're suggesting a solution to any business problem. They'll say they'll have something. They don't got it. I can promise you that. And then what do they actually want? And they'll tell you what they actually want. But trust me, when you start asking more questions, they don't know what they want. They don't say that, but they just don't. And I don't get it. But it's your job as a data scientist to act like a scientist and investigate thoroughly. So figure out what they have, figure out what they actually want, and then figure out if you have the tools needed to solve it. If not, figure out what those tools are and go from there. Can I construct, it's number C, is can I construct an input example small enough to solve by hand? And what happens when I try to solve it? So I'm not saying solve anything by hand. I typically, like if it's a new type of data input, I will try to see what that ideal output would look like. But I think this example is like, can I make a mini app? Can I make a MVP data usage that makes sense to the customer for them to see just so much of this working? Because a lot of people are skeptical, and this helps from a lot of people I've talked to. It helps a lot of people understand what's going on a little bit more and trust that you know what you're doing a little bit more by having something in hand. And it is also, in my opinion, the most frustrating thing because you're trying to figure out how to show them the simplest use case for something that is not simple. And it causes a lot of frustration. And we'll leave it there. So you need to understand what is the large or small amount of items they're dealing with. Are you dealing with small projects or millions of rows, thousands of rows? Like, do they even have enough input coming in for you to do anything on it? That's important. And if you don't look at that ahead of time and ask those questions in detail, you will be out of luck. If you start a project and then all of a sudden you're changing everything on them, they don't like that. The next step under that is, can I figure out a simple algorithm or heuristic for my problem? And it's basically, is there a simpler way to do this that is acceptable to the client now? If it's not acceptable to the client to change the method, like if they want a blockchain application, you can't change that. That's that. They want something built on that. But you can probably tell them, hey, TensorFlow and machine learning and AI is not what you need. You can solve this with simple analytics. I know those are buzzwords, but it's going to cost you a lot more money for a lot less results. Typically gets people's attention. And so you want to make sure that you find the simplest way to solve their problem because that saves your time. It saves complications. Most problems don't need AI or machine learning. Just people want to use them because they're buzzwords, and you get worse results, in my opinion, depending on the problem. So how do I measure the quality of the solution once I construct it? That's number 2. And basically, how are you verifying that you're actually delivering what they want? Are there certain metrics that you're measuring? Are there certain solutions or things that need to be there to make sure that's coming in? Is there a way to track that you had an outcome? And this helps you too, because I've never really worked in big companies. I don't like them. I find more freedom in freelancing, but and from a freelancer, this helps me show that I've done my job. And so I'm assuming it's the same way in a company. If you can make sure that your impact is well documented, it shows that you've done your job and you've done your job well. And I think the next one, can I solve my problem repeatedly using a simple thing? Like, is it going to break? When does it break? Those type of questions. Number 3 is my problem in the catalog of algorithms problems in the back of this book, which is another reason why I love this book. So let me find it. There's a lot of references. So here, let's just say there's like, I want to say a chapter or 2 of just the back. It just references everything. And so it's a great, here we go, algorithmic resources. Everything is back there. Everything is back there. And if you're starting with something in there like machine learning and AI, you might honestly just need an algorithm for it. So you want to check that. And you want to check, does it exist already? Has someone already built this? Is there a research paper I can read on it? Because data science is a field of the unknown. Sometimes we're working on problems, there's not a way to solve it, or working on something where they just found a way to solve it. You can't really know. So you try everything. But I would always start to see, has someone already done my use case? Is there someone already built an API for this particular image thing that I could use that would make my job simpler and allow me to push this project further? And so you always want to check your tools of the trade and see what's available to you. Is there a different way to do it? And going from there. And also, are you looking in the right place for the problem? Did you look at all of the information in the data sets? Because a lot of people will jump to assumptions before they go back and ask questions. So a data set is not abstract. It doesn't exist by itself. It exists in real world contexts that are affected by people. And so if you go back and you take a step back from the numbers and the information and you ask, what is this particular column representing? So like, I don't know, it could be this column is all the red flowers. And it turns out when you ask questions, the red flowers are grown in Maine, and these numbers are off because like some summer in Maine is short. I don't know. But you'll find out that. And this will tell you, like, am I actually making an assumption on the data, or is this some outside effects? So just think about that. And I'm trying to think of examples that I'm not under, like an NDA that I can't talk about. But it's not always black and white. It's sometimes you need to dig further into what does this data set represent. It's not abstract. It's tied to health. It's tied to growing something. It's tied to business objectives, and they're all affected by people. So you need to kind of understand what each column represents, and that will help you know if you're looking in the right space to solve that problem. Number 4 is, are there special cases of the problem that I know how to solve? Basically, can I solve the problem efficiently and ignore some of the input parameters? And the answer is sometimes yes. Sometimes they haven't structured their data architecture to make any sense at all. So you're stuck with things in your columns that make no sense. Your features, I say columns. See, they got all these terminologies, and I just like to be simple. So your columns, your features, you don't need them, or they're duplicates. And so by dumping them out, you're dumping out basically duplicate information or useless information. Like if the column is always 1, why do I need to know that? I just there's a trash can. Put it there. Save yourself time. Cameras. So simplify it yourself. Don't overcomplicate it. Don't try to seem like it's so much more than it is. You will get caught up in that and cause a lot of problems with all those extra data points. So, which of these standard algorithm designs paradigms are the most relevant to my problem? And this talks a lot about things like binary sources, size, sorts, random sampling. And to be honest, a lot of these can be applied to machine learning algorithms, how they're set up, what are best practices for the type of algorithms you like to use within machine learning. So I actually kind of want to get the hard book of Elements of Statistical Learning and go through that. But it's basically the same thing. Like, those are machine learning statistical algorithms, and they all follow certain requirements, and they are all existing paradigms. So you want to look at those, and you don't want to go out there and say, hey, I'm going to invent something completely new, because to be honest, it probably doesn't need it. So you can have fun on your own time. If you're getting paid to do it in a simple way. Check what is available, check what will like work, and make sure, like, in your head, which I don't have to do so much now because I'm freelance, and I try to take on particular types of problems, so I don't have to do this. But if you're in a company, having a running mental understanding of the different things out there and why they don't need to use it is important. I find that a very good way to say, hey, so you want to waste this computational time doing this because it's a fancy word, where you can do this in simple, or this is better because it allows 2 different data points, or it's all numbers, so we can do this. People like to know that, even if they like the buzzwords. So use that to your advantage. And then the last one, am I still stumped? Which the answer is normally yes. All the time. All the time. I will sit on a problem for a week and just be like, why, life? Why is there no Google answer for this? Why do I have to read all these research papers? And don't be ashamed to get help outside. I mean, obviously, if you're under NDAs, be very careful about what you're sharing. But sometimes, if you have a big enough company, I'm assuming there's someone that you can go to there. If you're like me, you don't. So you find a way to set up a similar problem to ask someone to just take a look at it and give you additional insight, or ask hypotheticals. Because sometimes people who are your peers just have experienced something different from you, and their insight is just very, very useful. And so you want to be open to that, and don't think that you're in it by yourself. If you're still in this field, with a lot of people are leaving because of the immense frustrations of stakeholders, and a lack of understanding between business and data. So I applaud you if you're still here. I am, or trying to be. But your peers, other data scientists, other data analysts, data engineers, machine learning engineers, all these different titles, they all have a different perspective. And so ask for help. Google, Reddit, Stack Overflow are all your friends. Say hi. They will be incredibly useful for you on your journey, and just learn how to search well. Learn how to break down a problem to, like, the root of the problem. So, like, if you're always searching on these things for the thing that you're seeing, and you're not understanding what the actual problem, like, is it oh man, error handling. Yeah, there's brain fart. Different types of errors that you don't know you're getting, or different processes. Like, once you start looking at the problem, it always breaks down into something in one of those, to be honest, a lot of times. And you just have to figure out how to break your problem down into those categories, and you'll typically find a solution, or enough to go on for that solution, unless it's a typing error, which I do that a lot and I don't catch, and it's a little frustrating. So yeah, cameras. This being a data science, and I like what he says here, problem solving is not a science, but part art and part skill, which is true. You have to develop the skills to be able to problem solve. And, you know, you have a scientific framework to go by. And, you know, just keep going. Have some fun. Always try to find the part of the job that you like, and keep going, you know. Always be learning. That's the only way to do it. Always be learning. Always be open to learning. And always be open to transitioning. I know some people who've gone from data science back to a data analyst because that's the part they preferred. Be open to that. If you don't like all these questions, become a data engineer. They don't have to answer all of these questions. They're not that person. They're the person that builds the pipes for you to do your job. So just be open to all of the different fields out there. So I'm not sure what part I'll cover next. It'll be something in part 1 when he's going over different type of, I don't know, algorithms. Or I might go ahead and jump into part 2, Patriarchal Guide to Algorithms. Yeah, I love that title. If you have not read that book, you probably should. It's cool. But yeah, we'll see. And I don't know. I'm finally coming out of quarantine fog of I don't really want to be at home. I don't want to be doing this. I want to watch TV. Watch a lot of TV. A lot of TV. I haven't watched that much TV in years. But we're coming out of that and we're getting back on top of things. And I'm part bored, part procrastinating. So I'll definitely post something else. Not sure what. Just